All right, welcome to another deep dive. I love it when listeners send us stuff like this,
Hmm.
especially about, the universe, big topics, mysterious topics. So this time we're diving into this Spanish YouTube video. Someone sent us about 9
Oh, wow.
mind-blowing theories about the universe. I mean,
Oh, good.
everything from multiverses and simulations to even universes born from fire.
Perfect.
So we've got it all translated for you.
Great.
So just buckle up, because this is going to be a wild ride. Some of these theories might just make you question, like, everything you thought you knew.
Fasten your seatbelts indeed.
Yeah,
We are going to be navigating through some seriously profound concepts,
absolutely.
trying to separate the science from the speculation.
Okay, let's kick things off with a concept that I think has always kind of captured my imagination. The multiverse.
Okay.
I mean, who hasn't wondered if there are other versions of themselves out there making different choices, living different lives? I mean, come on.
Right. It's a very tantalizing idea.
Yeah.
And it goes far beyond just another you making different choices. This suggests that there are entire universes
Wow.
that exist alongside our own, possibly even with different physical laws.
Whoa. Okay, so not just a parallel universe where I'm a rock star, but a universe where, like, gravity works in reverse.
Well,
But
let's
what
throw-
would that even look like?
Well, that's the mind-bending part, right?
Yeah.
Physicists like Max Tegmark and Brian Greene, they've actually proposed different levels of multiverses.
Oh, wow.
One that's particularly intriguing, I think, is what's called the level 2 multiverse. And this is where regions of space exist beyond our observable universe. And each one has its own set of physical laws.
Hmm.
So imagine a universe where time flows backward or where light travels at a different speed.
Yeah.
I mean, the possibilities are literally endless.
Okay, now that's seriously messing with my head.
Yeah.
As cool as it sounds, is there any way to actually prove any of this?
Right.
Or is it just a fun thought experiment?
That is the million-dollar question.
Uh,
So while the concept of the multiverse has actually been around for centuries,
what?
even dating back to ancient Greek philosophers,
Yeah.
it's still highly debated within the scientific community.
Mm.
Some see it as a fascinating philosophical idea, but one that's not scientifically testable,
Right.
at least not yet.
Okay.
Maybe one day.
So maybe we can't hop between universes for now, but hey, a deep dive into the multiverse is a pretty good substitute, right?
It's a start.
Yeah, exactly. Speaking of mind-bending concepts, this next theory really takes the cake.
Yeah.
The simulation theory.
Ah, yes. The idea that
Oh.
we might all be living
It's wild.
in a sophisticated computer simulation created by some advanced civilization.
It's like the Matrix in real life.
Exactly. And it's an
Yeah.
idea that's
Yeah.
really been popularized by the Oxford philosopher Nick Bostrom. And this gained traction in recent years, even among some prominent figures in science and technology, like Elon Musk,
Oh, yeah, I've heard him talk about it.
who suggests that the odds of us actually living in base reality are incredibly slim.
Okay, so if we're in a simulation, would we even be able to tell? Would we see, like, glitches in the Matrix?
Ooh.
Like deja vu or something?
That is where things get really interesting.
Okay.
Some scientists, like Homino Hadi, argue that a sufficiently advanced simulation might be completely undetectable.
Oh, wow.
Because if the simulation is powerful enough,
Yeah.
it can calculate and adjust for any anomaly that we might perceive. So we would essentially be living in a perfectly seamless virtual world, completely unaware of its true nature.
Wow. Okay, now that's a scary thought.
It's a bit unsettling, isn't it?
Yeah, it is. But not everyone's buying into this simulation hype, right?
No, not everyone. You've got scientists like Sabina Hassenfelder and George Ellis who are much more skeptical. They've even called it pseudoscience,
Oh, wow.
arguing that it's essentially untestable and unfalsifiable. So making it more of a philosophical exercise than a scientific one.
So it's like a cosmic what-if scenario.
But with some heavy hitters actually considering the possibility. Really makes you think, doesn't it? Okay, enough with the digital realm for now. Let's dive into something equally mind-boggling, but a bit more tangible. White holes.
Ah, yes. The mysterious cosmic cousins
Right.
of black holes. So while black holes are known for their immense gravitational pull,
Yeah.
trapping everything that ventures too close, white holes are thought to be regions of space-time where nothing can enter, only exit. It's like watching a black hole in reverse.
So instead of sucking everything in, white holes are just spewing stuff out.
In theory, yeah.
Where does it all go?
That is a question that has puzzled scientists for decades.
Yeah.
For a long time, white holes were considered just a mathematical quirk of Einstein's theory of relativity. But in recent years, there's been a growing interest in their potential connection to black holes.
Oh, so they could be two sides of the same cosmic coin.
Does that mean everything that falls into a black hole comes shooting out of a white hole somewhere else in the universe?
That is one of the mind-bending possibilities being explored. Some physicists speculate that black holes and white holes might actually be connected through wormholes, these tunnels through space-time that could allow matter and energy to travel vast distances or even to other universes.
Okay, now we're talking. Wormholes, other universes.
Yeah.
This is getting epic.
It's pretty wild, yeah.
Yeah. But as cool as it sounds, how do we even begin to study something as elusive as a white hole?
That's the challenge, right?
Yeah.
As physicist Carlos Rovelli points out, understanding white holes is proving to be even more complex than grappling with black holes.
I bet.
We're still in the very early stages of developing the theoretical framework and observational tools needed to study these enigmatic objects.
It's amazing how much we still don't know about the universe.
It is truly humbling, isn't it?
Yeah, it is. Okay, get ready for a deep dive into the very fabric of reality itself. The superfluid spacetime theory.
Ooh, this is a good one.
I'm already intrigued.
Get ready to have your mind stretched, because this one's a doozy.
Okay.
So imagine space-time, the very foundation of the universe.
Yeah.
Not as this empty stage, but as a substance.
Okay.
A fluid.
Right.
With zero viscosity, meaning it flows without any resistance.
Like a cosmic super smoothie.
Well, not quite.
Okay.
Think of it more like this. Imagine a silk scarf spread out on a table.
Right.
That's your space-time.
Yeah.
Now imagine tiny wrinkles forming on that scarf.
Okay, I can picture that.
Those are the distortions
Yeah.
caused by massive objects like stars and planets. And the superfluid spacetime theory suggests that these distortions, these wrinkles, are not just geometric curves, but actual ripples in this fluid-like substance.
Okay, so our entire universe could be swirling around in this cosmic soup.
Kinda, yeah.
I'm starting to feel a little dizzy.
I know, right?
But seriously, what does this theory actually explain?
Well, one of the most fascinating implications is its potential to explain galaxy formation.
Okay.
So think about it. If space-time is a fluid,
Yeah.
it can have vortices, swirls that could draw matter together,
Okay.
eventually leading to the formation of galaxies.
So those cosmic swirls are what created the Milky Way.
Potentially.
That's incredible. All right, I'm ready for the next mind-blowing theory.
Right.
Bring on the fire.
You got... Let's talk about the ekpyrotic universe. It suggests that our universe actually goes through cycles of birth, cooling, and fiery rebirth, rather than just a single Big Bang event.
So instead of a one-time cosmic explosion, it's more like a cosmic bonfire that keeps reigniting.
That's a great analogy.
Yeah.
So in this model, the universe arises from the collision of what are called branes,
Okay.
not from a singularity like in the Big Bang. It's a completely different origin story.
Okay, so how does this theory explain what came before our current universe? Did something else collide to spark the Big Bang? Or what?
Well, the ekpyrotic model suggests that what we call the Big Bang was actually a big bounce,
Okay.
a transition from a previous contracting phase to our current expanding one. So imagine a universe collapsing in on itself,
Yeah.
reaching a point of extreme density,
Okay.
and then rebounding outwards,
Wow.
creating this new cycle of expansion.
So it's like a cosmic inhale and exhale. Breathe in, crunch, breathe out, expand.
I like that.
Yeah.
Yeah.
That's kind of poetic, actually. But how does this theory stack up against the widely accepted Big Bang theory?
Well, that's a great question. So while the ekpyrotic model offers this different origin story,
Yeah.
it actually agrees with some key observations that support the Big Bang, like the cosmic microwave background radiation, the faint afterglow of the early universe.
Wait, so two completely different origin stories can both explain the same evidence. How is that possible?
Well, that's the beauty and complexity of cosmology.
I know.
Right.
Yeah.
Multiple theories can sometimes account for the same observations, at least to some extent. It's up to scientists
Yeah.
to gather more data, refine those models, and see which theory ultimately holds up better.
It's blowing my mind. All right, let's go back to basics for a minute and talk about the Big Bang theory itself.
Right.
I think we all need a little grounding after all these mind-bending concepts.
Back to the classic.
Right.
So the Big Bang Theory is, of course, the most widely accepted
Yeah.
model for the origin of the universe.
You know, it's funny to think that the term Big Bang was actually a derogatory nickname
I know, right?
coined by Fred Hoyle,
Yeah.
who is a staunch opponent of the theory.
Ironic, isn't it?
It's crazy.
Yeah.
But the name stuck.
It did.
And now it's hard to imagine calling it anything else. So the Big Bang Theory, just to recap, posits that the universe started from an incredibly hot, dense point and has been expanding and cooling ever since. It's amazing to think that all the matter and energy in the universe, everything that we see, everything that we know, was once packed into this tiny, unimaginable point.
Yeah, it really boggles the mind, doesn't it?
It does. And we have some pretty compelling evidence.
So the Big Bang.
For example, we have the cosmic microwave background radiation, that faint afterglow of the Big Bang itself.
Right.
But there's even more to it than that.
Oh, absolutely. Like Edwin Hubble's discovery that the universe is expanding.
Oh, yeah, I remember learning about that in school.
Mm-hmm.
But what does expanding even mean
Right.
in this context?
Yeah, it's not like the galaxies are just flying apart
Right.
in space.
Yeah, it's not like an explosion.
Exactly. Exactly. The expansion of the universe isn't about galaxies moving through space. It's about the fabric of space-time itself stretching.
Oh,
So imagine drawing dots on a balloon and then inflating it.
okay.
The dots themselves aren't moving,
Right.
but the space between them is growing.
That's kind of what's happening with the universe.
Well, okay, that's a much better visual.
Yeah.
So it's not like an explosion scattering debris outward. It's like the universe itself is getting bigger, stretching in every direction.
Exactly. And that expansion actually leaves this very specific fingerprint, redshift.
Okay.
So as light from distant galaxies travels through this expanding space-time, its wavelength gets stretched, shifting towards the red end of the spectrum. And this redshift is one of the key pieces of evidence supporting the Big Bang Theory.
Okay, so redshift is like a cosmic speedometer telling us how fast the universe is expanding.
That's a great way to think about it. And here's another piece of evidence that supports the Big Bang. The abundance of light elements in the universe, like hydrogen and helium. These were forged in the intense heat and pressure of the early universe.
Wow.
Just minutes after the Big Bang.
So the universe started out as a giant cosmic pressure cooker, creating the ingredients for everything that came after.
I love how this is all coming together. But hold on. We were talking about rival theories to the Big Bang, right?
Yes, yes.
I'm curious about those.
Yeah, so there have been some contenders vying for the title of the ultimate origin story,
Okay.
like the steady state theory,
Okay.
which refused to go down without a fight.
Ooh, tell me more. I love a good scientific rivalry. What's the steady state theory all about?
Well, it proposed that the universe is infinitely old
Okay.
and constantly expanding,
Right.
but new matter is continuously created to keep the density constant.
So it's like an ever-flowing cosmic river, always changing, but always the same.
That's a really nice way to put it.
That's a really cool concept.
It is.
Yeah.
And it was championed by some brilliant minds like Fred Hoyle, Thomas Gold, and Herman Bondi. Even Einstein briefly flirted with the idea before abandoning it.
Wow. So what happened? Why didn't this theory stick around? It sounds pretty elegant, actually.
Well, as elegant as it might seem, it ultimately couldn't withstand the weight of observational evidence.
Observations.
Right. Those pesky facts.
Yeah, those pesky facts always seem to get in the way. What kind of observations challenged the steady state theory?
Well, the discovery of quasars, these incredibly bright and distant objects,
Right.
thought to be powered by supermassive black holes,
Okay.
posed a major challenge.
Okay.
Because quasars are only found at very large distances, which means they existed in the very early universe.
Okay.
And that contradicts the steady-state model's idea of an unchanging universe.
So quasars are like ancient relics from a time when the universe was very different.
Exactly.
Wow.
And then, of course, there's the cosmic microwave background radiation
Right.
That we talked about earlier.
Right.
That faint afterglow of the Big Bang.
Yeah.
It simply couldn't be explained by the steady-state model, which didn't allow for a hot, dense beginning to the universe.
Okay, so it seems like the Big Bang is the reigning champion, at least for now. But you know what? All this talk about cosmic origins and the vastness of the universe has me thinking, Are we alone out there?
Now, that is a question that has captivated humanity for centuries.
I know.
So let's shift gears a bit
Okay.
and talk about those special planets that might be just right for life.
Okay.
Goldilocks planets.
Ah, yes. The cosmic real estate everyone's looking for.
Exactly.
But what makes a planet a Goldilocks planet?
So the Goldilocks principle states that a planet needs to be just the right distance from its star.
Okay.
Not too hot, not too cold,
Yeah.
but just right for liquid water to exist, and therefore potentially life as we know it.
It's just like the fairy tale.
Exactly.
Too hot, too cold, but the porridge in the middle is just right.
Mm-hmm.
Okay, that's a great way to remember it. So are we actually finding these Goldilocks planets out there?
Absolutely.
Wow.
So the Kepler mission, which was specifically designed to hunt for exoplanets, planets orbiting other stars,
Right.
it has found billions
Whoa.
of potential Goldilocks planets in our galaxy alone.
Billions. Billions. That's incredible. Does that mean we're not alone in the universe?
Well, it's certainly a tantalizing possibility.
Yeah.
But finding a planet in the habitable zone is just the first step. It doesn't guarantee that life actually exists there.
Right. So finding a planet that's just the right temperature is one thing.
Right.
But finding one that also has breathable air,
Yes.
continents, oceans,
It's a whole other ballgame.
that's a whole other level of complexity.
It's this complex interplay of factors,
Mhm.
and we're still learning
Right.
what makes a planet truly habitable.
Okay. So finding another Earth is a tall order. But hey, the universe is a pretty big place, right? Speaking of big, let's dive into the world of the elusive sterile neutrino.
Ah, yes. The mysterious particle
I know.
that could hold the key to unlocking some major cosmic mysteries. But first, let's talk about regular neutrinos.
Okay.
So you know that they are tiny, nearly massless particles that rarely interact with matter, right?
Yeah, they're like cosmic ghosts passing through everything.
Exactly.
Almost impossible to detect.
Now imagine an even more elusive neutrino,
Oh, wow.
one that interacts only through gravity.
Okay.
That is the sterile neutrino,
So it's like a ghost that's even harder to detect.
pretty much.
Why are scientists so interested in finding them? I mean, are they just trying to collect the whole set of cosmic ghosts?
Well, they could be much more than just cosmic ghosts.
Okay.
They're thought to be a candidate for dark matter, the mysterious substance that makes up about 85% of the matter in the universe.
Wait, so these tiny ghost-like particles could explain one of the biggest puzzles in the universe.
They could.
That's incredible. But how do we even know dark matter exists if we can't see it?
Well, we know it exists because of its gravitational effects on the visible matter in the universe. So, for instance, galaxies rotate faster
Oh, wow.
than they should, based on the visible matter alone. And galaxy clusters are held together by a gravitational force far greater than what their visible mass can account for.
So it's like an invisible hand holding everything together.
That's a great way to put it.
Uh-huh.
And sterile neutrinos, with their weak interactions, could be the missing piece of this puzzle.
Okay, I'm officially on the sterile neutrino bandwagon now.
Right.
But have we actually found any of these elusive particles?
Not definitively yet. There's an experiment called the Mini Boon experiment at Fermilab that hinted at their existence. But those findings are still being debated
Oh, okay.
and need further confirmation.
Right.
So the search for sterile neutrinos is ongoing,
Mm-hmm.
and it's one of the most exciting frontiers in particle physics.
This is why I love science.
Me too.
It's a never-ending quest for answers. And the universe always seems to have more surprises up its sleeve.
Absolutely.
Yeah.
We've only just begun to scratch the surface of what's out there.
Yeah.
It's fascinating how these theories about the universe, they often kind of reflect our own anxieties and aspirations, don't they?
Oh, absolutely. Like the simulation theory. Doesn't it feel like a product of like our digital age? Where we're constantly questioning, the nature of reality,
Right.
blurring the lines between, the physical and the virtual.
Exactly. It's almost as if we're projecting our own, technological anxieties onto the cosmos
Right.
and the multiverse with its infinite possibilities.
Yeah.
Doesn't it speak to our, our deep-seated desire for second chances, different paths not taken?
It's like a cosmic what-if machine, letting us explore all the roads not traveled.
Yeah.
Or maybe it's a way to like cope with the overwhelming vastness of the universe.
Right.
A way to feel less alone in this cosmic expanse.
Yeah, I think there's a bit of both at play.
Yeah.
We're driven by this innate curiosity to understand our place in the cosmos, to grapple with those big questions.
Yeah.
But also a need to find meaning and connection,
Right.
to feel like our existence matters even in the face of,
Yeah.
such vastness.
Speaking of connection,
Yeah.
let's go back to the white hole theory for a second.
Okay.
So if white holes are,
Bring it out.
spewing out matter and energy, where does it all go? Could it be creating new universes, like some kind of cosmic fountain?
That's one of the truly mind-boggling possibilities
Right.
that some physicists are exploring. Right. Imagine white holes as these cosmic birth canals.
Okay.
Spewing out the building blocks of new universes from the remnants of collapsed ones.
Whoa, hold on. So it's like a never-ending cycle
Yeah.
of creation and destruction,
Right.
with black holes and white holes acting as like
Yeah.
cosmic gateways between universes. That's seriously next level.
That is pretty wild.
But if this is happening, wouldn't we have detected these white holes by now?
Yeah, you'd think so, right?
I mean, they sound pretty dramatic.
Well, that's the catch, right?
Yeah.
Detecting a white hole directly is incredibly challenging, even more so than detecting a black hole.
Yeah.
Because remember, nothing can enter a white hole,
Right.
not even light. So we can't observe them in the traditional sense.
So we're relying on indirect evidence, like theoretical models and maybe some weird gravitational anomalies.
Exactly. We're still in the early stages of understanding these phenomena. It's like trying to piece together a puzzle
Yeah.
with only a few pieces.
That's what makes it so exciting, right?
Absolutely.
There's so much we still don't know.
Yeah.
So much left to discover.
It's like the universe is this giant mystery novel,
I know. I love that analogy.
and we're just starting to read the first chapter.
Exactly. Speaking of exploration, this whole discussion about different origin stories for the universe.
From the Big Bang to the ekpyrotic universe, it's got me thinking about our place in time.
Okay.
I mean, we perceive time as this like linear thing,
Yeah.
moving from past to present to future. But what if that's just like our limited human perspective?
The arrow of time. It's a fundamental concept in physics, but it's also, a philosophical conundrum. We experience time as this one-way street.
Yeah.
But the laws of physics themselves, they don't seem to care about the direction of time.
So you're saying time might not be this straight line, we imagine. Could it be more like, I don't know, a spiral or a web or something we can't even comprehend?
Exactly. There are theories that suggest that time might be more cyclical. Like the ekpyrotic universe model we talked about,
Right.
where the universe goes through these cycles of expansion and contraction.
Right.
Or it could be, multidimensional.
Where different timelines exist alongside our own.
Okay, that's making my head spin. So are you saying that instead of a single timeline, there could be multiple versions of history
Potentially.
playing out simultaneously, like alternate realities branching off with every decision?
That's one way to think about it. So it's a mind-boggling concept.
Yeah, I know.
But it is a possibility that some physicists are taking seriously.
This is seriously messing with my understanding of reality. Okay, let's bring it back down to Earth for a second, literally.
Okay.
We've been talking about these like grand cosmic concepts, but what about the search for life as we know it? We touched on Goldilocks planets earlier.
Yeah.
But what are the chances of actually finding another planet that's truly like Earth?
That is a question that's driving a lot of current research
Yeah.
in astrobiology.
Yeah.
So while we found many planets in the habitable zone,
Right.
Planets that could potentially support liquid water.
Yeah.
Finding a true Earth twin with the same atmospheric composition,
Right.
the same geological features, the same delicate balance of conditions that allowed life to flourish here on our planet,
Yeah.
that's a much bigger challenge.
So finding a planet that's just the right temperature is one thing.
Right.
But finding one that also has breathable air, continents, oceans, that's like winning the cosmic lottery, right?
It's a long shot, for sure.
Yeah.
But, the universe is vast.
Right.
And we're constantly discovering new planets.
Yeah.
The more we explore,
Yeah.
the better our chances of finding that, that rare gem.
Right.
A planet that truly mirrors our own.
It's like searching for a needle in a haystack, but a haystack the size of the universe.
Yeah, pretty much.
But even if we find a planet that's perfectly suited for life.
Hmm.
Does that mean life actually exists there?
That's the ultimate question, isn't it?
Yeah.
So, we could find a planet
Yeah.
that looks identical to Earth with oceans and continents and a breathable atmosphere, but it could still be completely barren.
Right.
Or it could harbor life forms so different from anything we can imagine
Right.
that we might not even recognize them as life.
Okay, that's both exciting and
I
terrifying.
know, right.
I mean, what if we're looking for life in all the wrong places,
Hmm.
with all the wrong assumptions about, what life should look like?
That's why it's so important to keep an open mind,
Yeah.
challenge our preconceived notions,
Mhm.
and be prepared for the unexpected. The universe is full of surprises,
Right.
and the discovery of extraterrestrial life, if it happens, will likely be, one of the most paradigm-shifting events in human history.
Okay, speaking of paradigm-shifting events,
Yeah.
let's circle back to the sterile neutrino, which, if it exists,
Hmm.
could hold clues to the nature of dark matter.
Right.
And that, as you said earlier, could revolutionize our understanding of,
Mm.
the universe's structure and evolution.
Yeah, it's amazing to think that this tiny, elusive particle
I know.
could have such a huge impact
Yeah.
on our understanding of the cosmos.
Yeah.
It's like finding a missing puzzle piece
Right.
that suddenly makes the whole picture come into focus.
This whole deep dive has been a roller coaster ride
It has.
through some of the most, mind-bending
Hmm.
ideas in science.
Yeah.
It's humbling,
Yeah.
awe-inspiring,
Yeah.
and it makes you realize just how much there is
Mm.
still out there.
Right. We've only just begun to
Yeah.
scratch the surface.
We've only just begun. It's amazing to think about just how much our understanding of the universe has evolved.
It really
It's
is.
like, we've gone from thinking that the Earth was the center of everything
Well,
to
sure.
realizing that, we're just this tiny planet orbiting a very average star
Mhm.
in this vast, possibly infinite universe.
Yeah, it's a humbling perspective shift for
Yeah.
sure.
Yeah, it is, and it makes you wonder, what other misconceptions are we clinging to today
Right.
that might be overturned by future discoveries?
Okay.
What other truths are we taking for granted that might turn out to be completely wrong?
It's a great question.
Mm.
And it's like that famous quote that's attributed to physicist Richard Feynman.
Oh yeah.
The first principle is that you must not fool yourself.
Mm.
And you are the easiest person to fool.
I love that quote.
Right.
Yeah, it's so true.
We have to be willing to question everything,
Absolutely.
even, our most cherished beliefs, if we really want to get closer to the truth.
Yeah, I think this whole deep dive has really stretched my brain, but in a good way.
It's good to stretch those mental muscles.
It is, yeah. I feel like I've gained this whole new perspective
Mm.
on the universe and on our place within it.
Yeah, that's the power of these mind-bending theories, right?
I know.
They challenge our assumptions, they expand our horizons,
Yeah. Yeah.
and they really make us look at the world
Yeah.
and the universe with, with fresh eyes.
It's like we've been given a new pair of glasses,
Mm-hmm.
and suddenly everything is in sharper focus,
Right.
more vibrant, more full of possibilities.
Exactly. And who knows what other amazing discoveries await us in the future,
I know.
right? With every new generation of
Oh,
telescopes,
right?
every new experiment, every new theoretical breakthrough.
Yeah.
I mean, we're pushing the boundaries of knowledge further and further.
It's an exciting time to be alive, that's for sure. And it all goes back to that sense of wonder, that innate human desire to explore, to understand, to connect with something bigger than ourselves.
Absolutely.
Yeah.
That's what drives us to look up at the stars,
Right.
to ponder those mysteries of the universe, to seek out the answers to the big questions. Where do
Yeah.
we come from? Are we
Yeah.
alone? What is the meaning of it all?
Right, and it's a journey that never truly ends, It's a quest that will likely continue as long as humanity exists.
It will, yeah.
And that's a beautiful thing.
It is.
It is. So, to our listeners, never stop exploring, never stop questioning,
Mm-hmm.
and never lose that sense of wonder.
The universe is waiting to be discovered,
It is.
and the adventure
It really is.
is just beginning.
Okay, that was another incredible deep dive. My brain is officially full, but in a good way.
It's good to stretch those mental muscles.
It is. And to our listeners, we hope this deep dive has sparked your curiosity
Yeah.
and inspired you to kind of explore these amazing theories further.
Keep looking up.
Keep looking up, exactly.
And keep wondering.
And keep wondering. The universe is full of surprises.
Absolutely.
All right, and that's a wrap on another mind-bending episode of The Deep Dive. We'll be back soon with more explorations into the unknown.
Until then, never stop exploring the universe and never stop questioning what you think you know.